Today we are looking at the audio mixer a little bit more. We're going to look at two particular features that allow us to interact with the mixer levels and the effects we can add to our mixer groups. The first is called exposed parameters and the second is called snapshots. Not only will we learn how to use the two, but we'll also look at the differences between them and how they affect each other. So let's start with exposed parameters. Now, as your player enjoys your game, you may wish for some of the game's mechanics to affect and change some of the fields you've set on your audio mixer, such as the effects or levels. For example, many games have audio settings and menus built for players to turn different parts of the soundscape, such as sound effects, music or dialogue, up and down. Well, using exposed parameters, we can set this up. We can use a C# script to first check for whatever value the music slider has been set to, and then change the level of our music group's volume field. We'd first have to expose it as a parameter, meaning we're giving permission to Unity's engine and API to control it, and then just set it to the same value as the music slider. Now, unfortunately, the Tanks game that we've been adding audio to doesn't have a pause menu with audio settings for us to attach this kind of behavior to. So in order to practice using exposed parameters, we're instead going to be increasing the pitch of our music slightly and speeding it up whenever a tank collects one of our power-ups to sonically notify the player that the power-up is in effect. So let's get started. The first thing we'll need is to expose the pitch of our music group in our audio mixer as a parameter. So first, make your way over to your audio mixer window. Next, select your music group and you'll see a slider at the top of the inspector tab that allows us to control the pitch of any music that passes through this group. Or to expose it as a parameter for us to interact with, we first right click on it, then select expose pitch of music to script. Now, you may have noticed that the small tab that sits right at the end of your audio mixer window called exposed parameters changed from 0 to 1. Well, it's here that we can see all of the parameters that we've exposed, so let's check it out. So you can see that a name has been given to the pitch of our music group called myExposedParam. Now, when it comes to interacting with an exposed parameter in C#, we need to remember the name given to it so that we can point our script to it. However, we can change the name to help us remember it and better organize our parameters. So let's right click on it, select rename and call it something simple such as music pitch. And that's all we need to do in the audio mixer. Now let's look at what we need to write inside of our C# script in order to access it. So seeing as we're going to be controlling it as a power-up is collected, let's go back to our power-up audio script, which we attach to our power-up object. Okay, so once you're back in your script, the first thing we'll need to do is reference which audio mixer the parameter we want to control belongs to, as you can create multiple mixers in a single Unity project. To do this, we're going to use a reference variable, make it public, and then select the mixer in Unity's inspector tab. So let's write public, followed by the name of the class that makes up audio mixers, which is called audio mixer, and then give it a simple name such as mixer. Now, you may have noticed that a red error line has appeared under the class. It looks like Unity doesn't recognize audio mixer as a class and is telling us that one doesn't exist. Well, the reason why Unity doesn't recognize this as a class is because in order to access it and other classes that make up the API that forms our audio mixers and tells them how to behave, we need to add a new namespace to our script. Up until now, we haven't really needed to worry about the namespaces in our scripts, but if you remember back to the C# basic lessons in module 1, I briefly mentioned how certain namespaces allow our scripts to access different parts of Unity. The namespace that we need to interact with our audio mixer hasn't been included in our scripts because there's no point in telling our script to access a particular part of Unity's API and code that we weren't even using. But now it's time for it to be included. So at the top of our script, and this time I do mean right at the top, let's start by writing the keyword using, which allows us to access namespaces. Then let's follow that with Unity engine dot audio. As you finish writing that, you should notice that the red error line underneath our audio mixer class reference has been removed, because now our script has access to the part of Unity where that class does exist, so it recognizes it. So now we can go ahead and tell our variable to hold a reference to our main mixer through Unity later. First, however, let's look at telling our script to access and change the parameter we exposed inside of that mixer. Now here's how we're going to do it. Once a tank enters the trigger area around a power-up, we'll tell it to change the pitch of our music. Wait 10 seconds, as that's how long the effect lasts for, and then change the pitch back to its original value. Now remember, the way that we tell our script to wait for a given amount of time before doing something is by using a coroutine, so we'll need to quickly set one up. So underneath our onTriggerEnter function, let's create a new coroutine function by using the return type iEnumerator and call it speed up music. Next, we'll tell that function to trigger using the onTriggerEnter function. So right at the bottom of the function, but inside of the if statement, checking for a tank object, we'll use the start coroutine function to tell our new function to trigger. Great, now we just need to tell our coroutine what to do. So when it first begins, we'll start by telling it to access our mixer and change the value of our pitch. We'll do that by first accessing the audio mixer class using our reference variable called mixer. We'll then use a new function that belongs to the audio mixer class called setFloat. setFloat is simple. It allows us to choose one of our exposed parameters with float as its data type and set a new value. So inside the parameter brackets is where we'll pass the name of our exposed parameter as string data and then the value we want to change the pitch to as a float. Now remember that we changed the name of our parameter to music pitch, so we must write that exactly as we did earlier as a string in order for this to work. Next to that, we'll give the parameter its new value. Now we don't want to increase the pitch too much, only by a third or so. So let's set the value of our pitch to 1.3, as 1 is its default and starting value. Great, so now our music will speed up. Next we want to tell the coroutine to wait for 10 seconds before we change it back. The way we do that is by using the wait 4 seconds class, which we briefly looked at in our coroutine lesson. So to use it, we'll write yield return new wait 4 seconds, followed by parameter brackets. Then inside the brackets, we decide how long we wish our script to wait for, which as I said earlier, will be 10 seconds. So let's write that. Finally, we'll set the pitch back to its original value. To do that, we can simply copy the line we used to change it in the first place, and then paste it after our wait 4 seconds line. The only difference is that this time we'll set the pitch to 1 instead. Great, let's save our script and make some final changes to the prefab of the power-up object itself. So as we said earlier, we need to point our mixer variable to the audio mixer that contains our exposed parameter. To do that, have the power-up object prefab open and scroll down the inspector to the power-up audio component. Then we could use the public mixer field to search for and find our mixer. There's also one more thing to do. If we want this effect to set the pitch back to normal after 10 seconds, this object needs to be around for at least 10 seconds. If it's destroyed before this, then the script won't have a chance to make that final change and our music will be stuck playing too fast. Currently it's set to destroy itself after 2 seconds, but we can change that by changing the destroy object delay field on the power up script. So make sure you change the number 2 to anything higher than 10. And that's it. You can now save your prefab, jump into your game and test the effect. Okay, so take any one of your tanks, drive them into a power up and listen to what happens. And there we go, the music sped up nicely for 10 seconds and then returned to normal. Okay, so now we know what exposed parameters are and how we might interact with them. What then are snapshots? Well, snapshots serve a similar purpose to exposed parameters. They allow us to make changes to our mixer during runtime of our game. The difference is, where exposed parameters only allow us to change one thing at a time, a snapshot can make multiple changes across an entire mixer. Now, by default, whenever we create a mixer, a single snapshot is also created. This snapshot acts like a saved file or a picture of all the values and positions we've set our effects and level sliders to. If we want our audio settings to change, then we can create a second snapshot and make changes to our mixer for it to hold. We can then transition between the two snapshots and thus transition between the values set in each. A common use of snapshots in a lot of games is to filter the music when the game is paused by the player. Now, as mentioned earlier, the tank game doesn't have a pause menu for us to interact with. So in order to learn how to use snapshots, we're going to apply the same music filter effect whenever one of our tanks is low on health, as a sonic indicator to our players that one player is about to win and the other is about to lose. So let's get started. Okay, so to start, make your way back to your audio mixer so that we can create a new snapshot. Now, if you take a look on the left side of the mixer, you'll see a tab called Snapshots. In that tab, you'll also have one snapshot already in it called Snapshot. This is the default snapshot I mentioned earlier. This is created whenever we create a new audio mixer, and it's essentially holding all of the values used in our mixer. Now, we want to create a second snapshot to activate when our tanks are low on health, but before we do that, it's important to make sure that we keep our snapshots organized by giving them names that clearly tell us their purpose. A snapshot called Snapshot isn't really helpful to us, so we'll start by renaming it. Right-click on the snapshot, select Rename, and call it Tanks Full Health. Next, we need to create a new snapshot for when the tanks are at low health. To create a new snapshot, simply click on the plus icon that sits to the right of the word Snapshots. Then we'll call this new one Tanks Low Health. Great, now that we have a new snapshot, we need to give it, and our original snapshot, different values for our music group. The way we do that is by selecting one of them and then making changes to our mixer, so we'll start with the full health snapshot first. Click on the snapshot's name to select it. Now, any changes we make will be remembered by our snapshot. So let's start by adding a filter effect to our music group. Select the music group in the mixer, and then in the inspector tab, click on Add Effect and select Low Pass. Okay, now we need to change the values of this low pass filter to better suit how we want our game to sound whilst our tanks are at full health. Right now, the cutoff of our low pass filter is 5000 Hz. However, we don't want the music filtered at all during this time. So let's set the cutoff to its maximum of 22 kHz so that no filtering is applied. Now let's go back over to our Snapshots tab, select our low health snapshot, and take a look back at the Inspector tab. Notice how the cutoff is back at 5000. That's because we had our first snapshot selected when we changed it to 22 kHz. Now, when our tanks are low on health, we don't want our cutoff set to either of these two values, or probably want it even lower. So now that our low health snapshot is selected, let's set the cutoff down to 500 Hz instead. We can also turn the volume of our music group down a little bit to about 15 decibels. Now, if we select our full health snapshot again, the volume and the cutoff fields return to the positions we left them at. Great, so we're now all set to control these snapshots in a C# script. But here's a few quick things for you to remember about snapshots before we move on. If you right-click on a field that you wish to change using snapshots, you can choose how your field transitions between the two values. Take a look at these different options and feel free to experiment with them, listen to how they change the transitions and what kind of effect or feel that adds to the game. I'm personally just going to stick with a linear transition for my cutoff field. Next, if we look back at our snapshots on the left, you may have noticed that our full health snapshot has a star on it. This tells us that this is the starting snapshot and will be used first when our game first starts, which is what we want. However, if you wish to make another snapshot the default, simply right-click on a different one and select Set as Start Snapshot. Finally, it's worth knowing how snapshots might affect any exposed parameters you may be controlling in a separate C# script. If you're planning on exposing a field as a parameter and changing it via a snapshot, the moment a C# script interacts with the field as a parameter, snapshots will no longer affect or change that field. So it's generally best not to change any exposed parameters using a snapshot. Okay, now that we've covered all of those points, let's look at swapping between our snapshots using our tank's health. So in your assets folder, make your way to the tank health script attached to the prefab of the complete tanks file. Okay, so once you've made your way to the tank health script, the first thing you'll want to do is add the Unity Engine Audio namespace. Just like the Audio Mixer class, we're going to need it in order to access a new class called the Audio Mixer Snapshot class. So at the top of your script, under the other snapshots, let's write using Unity Engine .audio. Now let's look at referencing our two snapshots. Just like with our audio mixer, we need to point our script to the two different snapshots we wish to transition between. To do that, we'll also create public reference variables, which we will give references to in Unity. So in our script, let's start by writing public, followed by the reference type I just mentioned, audio mixer snapshot. We'll then give this variable a name. The first variable will hold a reference to our tank's full health snapshot, so we'll give it the same name for simplicity. Let's then duplicate this variable, but call the second one tank's low health. Finally, we're going to create a public float variable and call it transition time. This variable will hold in seconds how long it will take Unity to transition between our two snapshots, and thus the values that we've given them to hold. I'm going to set mine to 0.5 so that I get a fairly quick transition, but feel free to try different values and experiment with transition times. Okay, so now we have our reference variables and our transition time. How do we trigger the transitions? Well, this script has a function called take damage, which is called whenever a tank loses health. So let's scroll down and find that function. Here we are. So how do we tell it to change our snapshots? Well, look at the very first line in this function. We can see that the function first reduces the tank's health by a certain amount here. The float variable current health is what holds the health of each tank as the game is played. So it's after this line that we'll want to update our snapshots. Now we don't want to swap between snapshots every time a tank loses health, only when it gets significantly low. So we'll start by creating an if statement. We'll then use this if statement to check to see if the health of the tank drops below a third of its maximum health. So inside of the condition brackets, we can write m underscore current health is less than 33, as the maximum health of our tanks is 100. Alternatively, this script holds the max health of our tanks in a variable called m underscore starting health. So another way of writing this would be to say if m underscore current health is less than m underscore starting health divided by 3. Then inside of the body of the if statement, we'll tell our audio mixer to transition to a new snapshot. We'll start by calling on the snapshot we want to transition to, which is the low health snapshot. Next, we'll use a function that lives inside of the audio mixer snapshot class we're using, called transition to. Transition to is simple. All we need to do is pass a float value that represents how long we wish the transition to last, and it will then transition from whichever snapshot is currently active to the one we're calling it from, which in this case is our low health snapshot. So let's give it our transition time variable inside of the parameter brackets. Great, now when our tanks have less than a third of health, we'll hear our music filter to our low health snapshot. The last thing we need to do is tell this script when we want to transition back to our full health snapshot. If we scroll all the way down to the bottom of this script, we'll find a new function called onDeath, which triggers whenever a tank is destroyed. This is when we want our music to return to normal, so we'll set up another transition using this function. So inside of our script, let's this time write tank full health and then use the transition to function, and we'll again use the transition time variable to set the time. And there we go. Now all we have to do is save this script and open up our tank prefab file. Okay, once you've got your prefab open, take a look at the tank health script in the inspector tab. Select each of your audio mixer snapshot reference fields and assign the correct snapshot to them. Once we've done that, we can save the prefab file and test out our snapshots in Unity. Okay, so in order to trigger a transition, we're going to need to lower one of the tanks to less than a third of its full health. So let's take one of the tanks and fire shells near the other one to lower its health without blowing it up completely. And there we go, we just heard our music filter. So our script checked the new current health of our tank, found it was less than a third, and transitioned from our tank's full health snapshot to our tank's low health snapshot. Now if we destroy the tank completely, we should also hear our snapshots transition again. Brilliant, our tank's full health snapshot fades back in just like we wanted it to. And with that, we've now learnt about 2 ways that we can interact with our audio mixer using C# scripts. We can now use exposed parameters to control a specific field inside of our audio mixer using the mechanics of our game. And we can also transition between multiple pre-established changes using snapshots. As I mentioned during the lesson, feel free to experiment a bit with the things that our snapshots are changing, trying out different values to change to, different transition types, or even bringing in new effects during runtime. Once you feel comfortable with them, it's time to move on to our final challenge for this module. So make sure you're ready for it, as it's going to test you on a lot of different topics we've covered in this course. I'll see you there.